thank you for enabling us. Want to thank you for enabling us wake up today morning, feeling great. We pray that we do not face any internet disturbances throughout the day, and we can lively participate in class. In your name I pray and believe. Amen.
Amen. Thank you so much, Sanyu. Can you see my blackboard very well?
Yes,
Before you
teacher.
leave, Sanyu, you can see my blackboard very well?
Yes, teacher.
Okay, that's very good. We can start. Let me first confirm the number of people available here. Okay, the number of people, how many are we? We are 60, okay. I hope we are getting there. 60, I want at least 100. Okay. Okay. Last week on Tuesday, we left when I was talking about the midpoint, okay, midpoint of a line. On Wednesday, we didn't have lessons, you remember? So I'm picking it from where I stopped on Tuesday on midpoint, okay? To remind you a little, I said that given 2 points, if I have a point A with the coordinates x1, y1, and say that this is a point, and another point here B with the coordinates x2, y2, the midpoint, of course, will be here in the middle. And the coordinates of this midpoint will be given by, this is midpoint. Midpoint will be given midpoint M. Okay, midpoint will be given by, I'm putting M. It will be the average of the x coordinates. So it is x1 plus x2 out of 2. You add the x coordinates and divide by 2 to get the x coordinate of the midpoint. And then the y coordinate would be, the y coordinate of the midpoint would be y1 plus y2 out of 2. So it is as simple as that one. And that's what we said last time. So I want to pick it exactly from there. I want us to look at what we call the perpendicular bisector to a line. So from here, our next subheading is the perpendicular bisector. Perpendicular this is the perpendicular bisector. Perpendicular bisector. Okay, what is to bisect? Can someone tell us what bisecting means? Johanna?
To bisect is to divide something into 2 equal parts.
Yes, it is to divide something into 2 equal parts. When you are told to bisect an angle, say you are bisecting an angle of 60, you get 2 angles, each of 30 degrees. So to bisect is to divide something into 2 equal parts. What do you think is a perpendicular bisector now?
Teacher, I think a perpendicular bisector is a bisector at a 90-degree angle.
A bisector at 90-degree angle. Okay, thank you, though not very clear. Paul, I have seen your hand there.
So I think a perpendicular bisector would be like the bisector, the line that bisects the angle has to be perpendicular to the line it's bisecting.
I beg your pardon?
The line that bisects the angle that you're trying to bisect, so like the line, it has a perpendicular bisector would be the bisector has to be perpendicular to the line that you're trying to bisect to the angle.
Yes, that one is very true. The perpendicular bisector has to meeting that line angles. So the bisector and the line must be perpendicular lines. That is true. Then I want to dividing two equal parts because we have said that equal parts. So combine the two lines being perpendicular, and then that concept dividing into two equal parts. So that will be the perpendicular bisector. Someone is now putting the two together here.
A perpendicular bisector is a line that meets a line at a right angle and cuts it into two equal parts.
I beg your Jovia.
A perpendicular bisector is a line that meets a given line at a right angle and cuts the line into two equal parts.
Okay, that's very good. Now, cutting it into two equal parts, where will it pass?
The midpoint.
The midpoint is very good. Now, Jovia, can you give us the definition where we have meeting at right angles, and then you have to accommodate the word midpoint in your definition? So what will the definition be?
A perpendicular bisector is a line that meets a given line segment at a right angle and also passes through the midpoint.
That is very correct. That is very correct, Jovia. I clap for you. People, what we call a perpendicular bisector to a line is that line that is perpendicular or that meets the other given line at right angles and passes through the midpoint of that line. So that's what we call a perpendicular. That's what we call a perpendicular bisector. Okay, so a perpendicular bisector meets the given line at right angles, and at the same time, it goes through the midpoint of that given line. Okay, so I can write the definition here that this is the line, a perpendicular bisector. A perpendicular bisector is a perpendicular bisector to a line. A perpendicular bisector to a line is a line that meets the given line, that meets the given line at right angles and goes, okay, and passes through midpoint of the given line. A perpendicular bisector to a line is a line that meets the given line at right angles and it passes through the midpoint of the given line. If, for example, I want to illustrate it here, if I have this line, say line AB, this is A, and this is B. I can have coordinates X, Y1, and then the coordinates here, X2, Y2. Now, when we are talking about perpendicular of the line that is the perpendicular bisector to AB, we shall talk about that line that is perpendicular to AB and at the same time passing through the midpoint of AB. Okay? So, first of all, the perpendicular bisector will be perpendicular to AB. That's the first point. And at the same time, it is going through the, we can say, okay, this is M, the midpoint, and here you have x1 plus x2 divided by 2. You remember how we got the midpoint last time? Then y1 plus y2 out of 2. If these two conditions are satisfied, being perpendicular through the midpoint of AB, they say that this is the perpendicular sector of the AB, becomes the perpendicular bisector. Okay, can I get questions if they are there? That one is not connected. Okay, Rona.
Good morning, teacher.
Kainimbabazi.
Good morning, teacher. Can you?
My dear.
My question was, I don't understand why you put this part here of the midpoint there. Like, I don't understand that whole part.
Okay. We talked about perpendicular lines, and we said that perpendicular lines are those lines that meet at right angles. That's the definition of perpendicular lines. These are lines that meet at right angles. Yes? Now, the line AB can have very many lines that are perpendicular to it. Yes? But we have that special one that is going through the midpoint of AB. First, it is perpendicular, and second, it is going to the midpoint of AB. Now, that one has a special name, and the special name is perpendicular bisector of AB. We leave all the other bisector, we leave all the other perpendicular lines to AB, and then we concentrate on that one that is going through the midpoint of AB, and it is perpendicular to AB. We call that one the perpendicular bisector of AB. Is it okay?
Yes, thank you.
Okay, you are welcome. Is there any other question? Perpendicular bisector. No other questions. We can go straight to the examples. Okay? You have written the definition and you have sketched this one. If I have a line AB, the line that is perpendicular to it and it's going through the midpoint of AB, is what we bisector. So I want to go to examples. I hope that one is very okay and people have written what's on the board. Okay.
Teacher, this is not there in Google Classroom.
Sorry?
Are they not there in Classroom?
I sent the notes to this topic right at the beginning of the topic. The whole document at the beginning of the topic, so it must be there.
Teacher, it's in the old Google Classroom, but it's expired.
Okay, okay. Now we are concluding this topic today, by the way. So I'll have okay. Resend the topic still plus the summarizing exercise. Okay. So if this is okay, allow me to go.
Should we write you, or should we like the way they are in Google Classroom?
No, when I'm teaching like here, you have to keep writing things because I add in. You'll find that this definition is not there in the notes. This sketch is not there in the notes, but the examples are there. So I add in. That's why I give you some minutes to write what's on the board. Okay. Example. Okay, find the equation of the perpendicular bisector. Example. I can even write here. This is sample. Maybe the question. Example. Okay. Find the of the perpendicular bisector to the line A for 1 and B to 7 and B to 7. Okay, find the line, find the equation of the perpendicular bisector to the line through A 4 and B to 7. I hope you can see the question very well.
Excuse me,
Okay. And I
the teacher will tell you to find the equation. Is it like finding the midpoint?
Getting the be the first step. Very good. It will be the first step. It's not the equation. So it is a step 2. Is that okay? Okay.
Yeah.
Now, that's who is that one? I want us to look at the working here. They want us to get the equation of the line, get the equation of the perpendicular bisector to AB. A has coordinates 4, 1, and B has coordinates 2, 7. Are we there? So we want the equation of the perpendicular bisector. we say that the perpendicular bisector to AB must be perpendicular to AB. That is the first thing, perpendicular to AB and the point of AB. So who can I move?
Teacher Dav.
Dav, very fine. I like you, girl. You like math.
Thank you. So we first find someone said the first step is finding the midpoint, and the midpoint x1.
Let me first label this one. This is the perpendicular bisector. Okay, so the first step you have said that
we find the midpoint.
Because we need a point on this line.
The midpoint, the way we find the midpoint is x1 plus x2 divided by 2, and then the y coordinate is y1 plus y2 divided by 2. So we get, since we have the x and y coordinates of B and A, it will 4 plus 2 divided by 2 for the x coordinate.
Now, let's be a little slow. You have said that we are the midpoint of A.
To be x1. So we use I use the coordinates.
Yeah, use the coordinates.
Okay. It will be 4 plus 2. And the y coordinate will be 1 plus 7 divided by 2.
Good.
Then 6 divided by 2 and 8 divided by 2.
6 by 2 and then 8 by 2.
For the midpoints, coordinates is 3 and 4.
3 and 4. Very good. So, do you know what we have got? We now have a point on this line. So, since we have a point on this line, we now need the gradient of this line. After getting the gradient, we shall use the gradient at this point to get the equation of that line. So, Dav, what do we do next?
Did you first repeat the way you found the midpoint?
The way I found the midpoint.
Sorry, no, the way you calculate the perpendicular bisector. You said we do what?
Okay, I have said that we have now got a point on this perpendicular bisector, which is a line also. So we have got a point on the perpendicular bisector. We now need the gradient of this perpendicular bisector. When we have and the gradient, can get the equation of the line.
Is equal to mx plus c, I think.
Hey, Dav, have we got the gradient of this one?
Oh, well, we're getting the gradient, it will be, we have first get, right?
Y1 plus Y2.
Y1 plus Y2?
Bottom.
That one taking over. Dav, can you get someone to assist you?
I think 2 minus y1 divided by x2 minus x1. I think.
What will that one which gradient are you looking for now?
Well, the gradient of the second line, the perpendicular bisector.
Teacher, you write points in y is equal to mx plus c4.
Are you sure?
Why
You see,
minus y
Minus y divided by
okay, first wait, people. I can find here. Can you mute? Can you mute?
Teacher.
Jovia, can you say something?
The gradient of the line that has been bisected, and if they are perpendicular lines, the gradient of the arc is 1 times MC is equal to -1.
That is very good. Can you repeat it? Everyone listen to Jovia. Jovia, repeat it, please. Jovia.
Repeated.
Jovia, have you disappeared? So if you heard what Jovia said, can you take us through?
I think I heard, but she said that you first find the gradient of that line, B and F, then after, since they are perpendicular lines, you use M1 times M2.
Okay, that's very good. Who is that one?
Daphne.
That is Daphne. Okay, that's very good. To get the gradient of this perpendicular bisector, we need the gradient of AB. And since the two lines are perpendicular, the gradient of the perpendicular bisector will be got from M1 times M2 is equal to -1. So gradient of AB, is what we're looking for first. And remember, to get the gradient, we use in y divided by 2. So who is that one I'm moving with? The person I'm moving with, please, can you talk? We are looking for the gradient of AB. So it will be, remember,
y2 minus y1 divided by x2 minus y2.
Minus x1. So do the substitution.
Minus divided by -4.
-4, good.
And 6 divided by -2.
6 by -2, which will be -3. Now that is the M1. The gradient of this one, M1 is equal to -3. Is that okay?
Yes, teacher.
Now, how do I get M2, which is the gradient of the perpendicular?
M1 times
M2 is equal to
-1.
M2, that is one that is very good, people.
M1.
That's very good.
-3 M2 divided by -3 is equal to 1, 3, which is 1.
And M2 is equal to
1.
Yeah, that's our third. You see, step by step, we have now got the gradient of the bisector. The gradient of the bisector is our third. I'm very sure and I'm convinced that everyone now can get the equation of this line, because you have a point on the line and the gradient of the line. And remember, that's where we started from. Given a point and the gradient of a line, you can get the equation of the line. I hope that's okay to everyone.
Y is equal to mx.
We are now using y is equal to mx plus c. Very good. The point we are using is this m, which is this.
Will be substitute. 4 is
equal to a third 3 times 3 plus c. And then 4 is equal to 1 is equal to c.
Okay.
1 plus
c.
It's also c will be equal to.
Therefore, the equation of the line is.
Can we have person submit this?
From here, where
is equal to 3.
Okay. But it goes step by step. So
4
for my equal to c.
Okay. It will be 3 is equal to c.
To 3. Is that okay?
Yes, teacher.
The equation of the bisector, allow me to write it here because my space here is. So the equation of the perpendicular
add x plus c.
It will be Mr. Sekaita, yes, please.
Okay. The girls are going to submit to avoid too much confusion.
Okay, who is
I'm moving with their hands, we get one at a time.
Yes, you're moving with me, teacher.
So the final answer after getting the value of c is what?
The equation will be y is equal to a third x plus 3.
A third x plus 3, that is very good. So this is the equation, the perpendicular bisector to AB. Okay. People, can I go through those steps again very fast?
Yes.
We are told to get the equation of the line, the equation of the perpendicular bisector to AB. We said that the perpendicular bisector, first of all, is perpendicular to the given line. And then 2, it must be passing through the midpoint of the given line. So the first step was to get midpoint, which is a line on this perpendicular bisector. So after midpoint, we have to look for the gradient of this line. How do we get the gradient of that line? We need the gradient of AB. Then later we use M1 times M is equal to -1 to get the gradient of this bisector, which is M2. After getting the gradient of the bisector, and already have the point on that perpendicular bisector, which is M, then it means that we can get the equation of this line using this point and the gradient of that line. So there is a question, please ask.
Teacher. When we are finding an equation of the perpendicular bisector, like which it's used.
When we are getting the equation of this perpendicular bisector, we use the point M. M is on the bisector and at the same time on line AB. So we use M when we are looking for the equation of the perpendicular bisector. We can't use this one because the perpendicular bisector is not passing through this point B. We can't use A because the perpendicular is not passing through A. only midpoint, which is also on the perpendicular bisector.
Thank you, teacher.
Yes, Mr. Sakaita.
Add something small.
Yes, please. You are welcome.
Jean, by the virtue of the meaning of perpendicular bisector, perpendicular means intersect 90 degrees. And bisect, to divide into two equal parts. So by the statement perpendicular bisector, that line must be passing through the midpoint. That line must be perpendicular to the given line and passing through the midpoint. Why we use a condition of perpendicular lines, M1, M2 is equal to -1. We use point to find the equation of that line. Thank you.
Okay. Thank you, Mr. Sakaita. Thank you so much.
Thank you, teacher.
Do we have any other questions? Or satisfied?
I don't see any hand.
Okay. So that means that I've understood very
obviously.
I love you people. That's very good. So have you written this? I'm giving you 1 more minute to finish that. I know you have been writing.
Teacher.
Yes, Bonita.
There on M1 times M2 is equal to -1. Why do we use theory?
Mama Tumbe.
Also the negative of
gradient of M is -3.
Because
gradient substitute.
Is -3.
Mr. Sakaita, what is the question?
At a point of M1 times M2 equal to -1, why do we use -3?
Right. -3, the M is the gradient of the first line, and we call that one M1. So we're just substituting this one. M1 is the -3 times this M2 to get -3 M2. So I hope that's okay. Okay, you are welcome. Mr. Sakaita, my target today was and then we end the topic with the distance between 2 points. But it looks like these people need another example. How do you see, Mr. Sakaita?
Yeah, let's just give another example instead of going to the length of a line, because they still, if they ask why do you use 3, why do you use -3, there is something small.
Okay, yeah, so now we exhausted
let's give another example.
But okay, anyway, I had come to conclude the topic, but it looks like Mrs. Nampaj will do the distance between 2 points tomorrow. Let me give another question. Okay. Let me read another question from there. Okay, I only need the point. So example 2, find the equation, of the perpendicular bisector to the line joining P, the joining points P, help me with the points there, 10, 2, and the Q, 2, 4. Okay. Are we there, people? The question is there. Find the equation of the line, find the equation of the perpendicular bisector to the line joining points P 10, 2, and Q 2, 4. Okay. Angel Ntongo, do you have a question? I can see your hand up.
No, teacher, I don't have a question.
Okay, that's very good. So you are just saying, you are just saying hello to me.
I wanted to do that now.
Okay, Mrs. Kisambu, can you take over? I'm handing over to Mrs. Sambi here to take you through that second question.
So, Ntongo, how do we start?
Teacher, we start by finding the midpoint of P and Q.
Yes, we have a line P, PQ. Then we have this perpendicular one. So, yes?
So we are finding the midpoint, which is there between where the lines, where the perpendicular bisector cuts that point.
Yes. So we want to find this midpoint. How do we do that?
The midpoint of P and Q will be x1 plus x2 divided by 2, then y2, y1 plus y2 divided by 2.
Yes. So we substitute in the coordinate.
So that would be 10 plus 2 divided by 2, then 2 plus 4 divided by 2.
So
12 divided by 2. 12 divided by 2, then 6 divided by 2.
So our midpoint M is equal to?
M is equal to 6. 12 divided by 2 is 6, so that will be 6.
Yes. So we have found the midpoint. Remember, we are looking for the equation of this line, which is perpendicular to this other line PQ. So we have found the midpoint. What is the next step?
We find the gradient of the line PQ.
AQ, gradient of PQ would be equal to
y2,
y2 minus y1 divided by.
Can we have one person to submit?
y2 minus y1 divided by x2 minus x1.
Yes. So what is y2?
4 minus 2.
4 minus 2.
Divide by 2 minus 10.
Divide by 2 minus
10.
Minus 10. So that is the gradient. So what do we get?
I will get 2 divided by -8, 2 out of -8, which
So
is
gradient will be equal to 4 minus 2 is 2. And 2 minus 10 is -8, giving us
-1 out of 4.
So this is the gradient of the line PQ. Next.
Mr. Sam, I can see hands up. There is Tangaza.
Dav.
Next we shall be finding the gradient of the perpendicular line, of the perpendicular bisector, which will be x1 times m2 is equal to -1.
So the gradient of the line that we are looking for, which is the perpendicular bisector, M2 is equal to -1. So if this is our M1, which we are calling -1 out of 4, times M2. M2 is the gradient of this line, which is perpendicular to PQ. So times M2 will give us -1. So what is M2?
-1 out of 4 M2 is equal to -1. And then you multiply 4 on both sides.
Yes. So we shall multiply by 4 here and by 4 here. Then we shall get.
It will become -1 M2, -M2 is equal to -4.
-4. So
negative sides.
We shall divide by this -1. Divide by -1, and M2 is equal to 4. Thank you. So we have found the gradient of the line that we are looking for. But remember, the equation that we are looking for is in the form y is equal to mx plus c. So we have found m and we want to look for c. So how do we find c?
Namugabo.
We find C using, we use the points for the midpoint, and we also use M2 using y equal to mx plus c.
So the point that we are going to use here is this midpoint, which is 6 and 3. So we are using this point, and we already have M2. So here we need to substitute it because X here is 3, M is 4, X is 6. So we shall say that 3 is equal
to 4 in bracket 6 plus C.
Plus C. So what is C?
C is negative 21.
C is equal to negative 20.
Negative 21.
I hope everyone can see that, because this is 24. When you take it on the other side, it will become negative 21. So we have found the values of M and C. Therefore, we write our equation. So the required equation will be, Tonga is still on. Give us the equation.
Tongo.
The final equation.
The equation of the line will be y is equal to 4x minus 21.
4x minus 21. Thank you. So you conclude by writing this. The required equation is y is equal to 4x minus 21. I don't know whether there are some other questions. If you have a question,
Raise up your hands.
no question. Maybe in the remaining minutes, we can give you a number to try.
Yes, teacher.
Okay, I hope you have written this. Are you done with writing?
So
No,
we are
teacher.
giving you. If someone is still writing,
Yes, teacher, I'm still writing.
In 1 minute you must be done. You won't take the whole day writing. Thank you so much, Mrs. Sam. So that someone must be planning to finish. Okay. So I hope today we have understood what they call perpendicular bisector. Okay.
Yeah.
And I know we are very slow but sure.
Yeah.
Daniela Akero, you have a question?
Yes, teacher, I had a network issue and I joined in late, so I'm not sure about what we are doing. I haven't understood anything.
Daniela, you have not understood anything?
Yes.
About perpendicular lines?
Yes.
That
Okay. Thank you, teacher.
through passing through A negative 5, 6, negative 5, 6,
and 3,
and B is 3, 2. Okay. So find the equation of the perpendicular bisector. The line passing through A negative 5, 6, and B is 3, 2. So we are using the remaining minutes to get the answers. So I can see there the pen is moving very fast. So can you write? And then later we get the final answers. I can give everyone 2-3 minutes. And I think Mr. Bato, those are the ones we are left with, like 3 minutes. Okay. If you are done, you start giving us answers here.
Excuse me, teacher, is that -5?
Yeah, it's -5.
Okay, thank you.
Those who are done, you can start giving us your answers here.
Fortunate. Again,
Y,
wrote.
y equals 2x plus 7.
Plus 7, okay.
Next.
That's one. Another person. Is there another person? When you are done, you just tell us. We are waiting for the hands.
Teacher,
Yes.
I've gotten y is equal to 2x plus 6.
2x plus 6. Good. Another person. Those are two so
And
far.
Grace. And Grace.
I also got the same as Dav.
Dav is this one.
Yes.
Okay, another person. I'm ticking because okay, we have a second person for this. Joanna.
I got the same as Dav.
Hey, okay, so that is getting a second tick. I have not confirmed any answer here.
Cynthia.
I also got the same as Dav.
Okay, that is getting some tips here. Another person.
Y is equal to 2x plus 2.
Y is equal to 2x plus 2. Who is that one?
Esther.
Okay, Esther, good.
So I got y is equal to 2x plus 6.
Okay, another tick there.
I also got y into x plus 6.
Yes.
I got number as answer.
Another tick there. Some are there in the Google answered that one. Excuse me, teacher. Why do we find it's because those are perpendicular lines, and we have to get the gradient of the second line. They are not parallel lines. So another answer for the is 2x. Okay.
Then 4x plus 20.
4x. That's another part. Is there another answer? 2 more people?
Sure. 2x plus 1.
Okay, I've seen another one with this one. Okay, people. The answer is this one. The final answer is this one. I'm very sure you got the point as -1, 4. That's the midpoint. 1 is the gradient of the first one as -half. And this implies that M2 is 2. Are we there? You got C as 6, and the final answer is y is equal to 2x plus 6. Okay, so midpoint is this one. M1 is -half. M is 2. C as 6. The From the perpendicular bisector is y is equal to 2x. We want to stop the people. We want to stop here. Topic will be completed tomorrow. I overestimate what to do today, but last part will be covered tomorrow. Thank you for attending. Thank teachers who are here with me and they are in the background. Have a very good day.
Have a good day.